You picked microservices because you wanted speed, faster teams, faster deploys, faster change. But somewhere along the way, a simple feature stopped being simple. Now that same feature means a new ticket, two team handoffs, an API review, and contract checks. You have to manage retries, tracing, and rollout planning while someone asks who actually owns the change. The old bureaucracy didn't disappear. It just moved. It moved out of the org chart and directly into the runtime. And that's not just a feeling. Current research shows 42% of organizations are consolidating services back into larger deployment units. That should tell you something. In this video, I'll show you the model behind that slowdown. We will look at why net teams feel it early and what to do instead. Because if you keep the current model, you keep paying in latency, coordination, and delivery trust alone. Now, the architectural illusion of progress. Microservices were sold as autonomy. The idea was to split the system up, give teams ownership, and deploy independently. You would scale only the parts that needed scaling. On paper, that sounds clean, that sounds modern, it sounds like maturity. But the model came with assumptions most teams skipped right past. It assumed your domain boundaries were already clear and your teams were stable. It assumed your platform was mature enough to absorb the extra operating load without slowing down feature work. In a lot of companies, none of that was true, yet the architecture still shipped anyway. That's where it breaks. Because the architecture starts asking more from the organization than the organization can actually provide. Research around modular monoliths and microservices keeps landing on the same pattern. Microservices pay off later, not early. For teams under roughly 20 to 30 engineers, the coordination cost often beats the scaling benefit. You don't get independence, you get dependency with more steps. And one level deeper, the performance story gets distorted too. Inside one process, code talks at memory speed. Across services, that same conversation turns into network traffic, serialization, and auth checks. You deal with timeouts, retries, and logging. That move takes you from nanosecond level calls to millisecond level calls. People hear that and think milliseconds are still fast, but that misses the point. The problem isn't one call. The problem is what happens when business logic gets scattered across a chain of calls. Every small change now crosses boundaries that didn't need to exist. So what used to be one code change becomes many forms of coordination. A business rule changes in pricing. That now touches an API contract, a consumer expectation, and another repo. You have another pipeline, maybe a message schema, and maybe an approval from a team that's busy with something else. The code might take 30 minutes. The system around the code takes days. Still, it looks like progress from a distance. More boxes on the diagram, more service names, more ownership labels, more governance. It feels structured, and structure often gets mistaken for capability. This is especially true in enterprise IT, where visible complexity can look like serious engineering. But adding boundaries doesn't automatically create clarity. A lot of the time, it just creates more places where work can stop. That's why so many teams end up rebuilding the same silo behavior they were trying to escape. Only now the silos are technical. One team controls one service while another team controls a dependent one. Every boundary becomes a negotiation point. Every negotiation point slows the flow of change. And once the model fragments the flow of change like that, the tax starts showing up everywhere. The hidden tax of distributed complexity. Once the change path gets split, the next problem shows up in the system itself. A lot of teams think speed drops because the code got messy, and while that is sometimes true, the slowdown in distributed systems often starts much earlier. It happens because the architecture forces work to travel across the network when it never actually needed to leave the process in the first place. That decision brings extra mechanics with it, and every single mechanic has a cost. One request becomes many moving parts. You serialize data, you send it over HTTP or gRPC, and then you authenticate it. You wait on another service, you handle timeouts, and you add retries. You log correlation IDs, you emit spans, and you deal with partial failure. And if one downstream service slows down, the service above it starts carrying that pain too. None of this is fake work, and some of it is necessary in the right context, but a lot of teams are paying this price on flows that are still basically one business transaction. That's why distributed complexity is so deceptive. From the outside, each service can look small and neat, but inside production, the full request path is heavier than the diagram suggests. The real system includes everything between those services, not just the services themselves. The payload formats matter, the network matters, and TLS matters. Under load, details like retry behavior and backoff settings stop being details. Observability shows this clearly, but it comes with its own bill. Distributed tracing gives you the map you need when one request touches 5, 8, or maybe 12 services, but tracing isn't free. Research shows throughput can drop by 19% to 80%, and median latency can rise by 7% to 42%, depending on how instrumentation gets implemented. So the team ends up in a strange loop where they distribute the system, then add more infrastructure to explain the distribution, and that extra infrastructure adds more load again. Small teams feel this first because they don't have spare capacity. They're already building features, fixing incidents, maintaining pipelines, and answering questions from the business. Then the architecture asks them to become experts in telemetry, container networking, retry policy design, and failure analysis across service boundaries. Now, the team is not just writing a netcode. It's running a distributed platform. And in .NET shops, service mesh decisions can push that cost even higher. The upside of a mesh is real because you get traffic control, MTLS, and policy enforcement without baking all of it into every app. But the overhead is real too. Research on 2026 mesh trade-offs shows Istio sidecars commonly add around 50 to 100 megabytes of memory per pod, plus 2 to 5 milliseconds of P99 latency overhead under load. Linkerd is lighter, often around 10 to 20 megabytes and under 1 millisecond, but even that still consumes capacity your app no longer owns. That matters when a net API pod already carries a heavier memory profile than many teams expect. Now add a sidecar proxy to every pod, multiply that across a cluster, and suddenly platform logic starts eating the app budget. The team thinks it bought safety, but what it also bought was more memory pressure, more node cost, and more tuning work. Then Kubernetes enters the picture, and the learning curve climbs again. Scheduling, autoscaling, probes, limits, requests, networking, certificates, and policy YAML. You can't call that free speed. Debugging is where the tax becomes impossible to ignore. In a single process, you follow one stack trace, but in a distributed chain, the truth is fragmented across logs, traces, message brokers, and timing gaps between services. Research comparing modular monoliths and microservices points to around 35% more debugging time in microservice environments. That sounds abstract until a production issue burns half a day and nobody can answer one basic question: where did the request actually fail? So this stops being just an engineering taste debate. It becomes a staffing issue because distributed systems need more operational care. It becomes a cost issue because observability, proxies, and orchestration all land on the cloud bill. And it becomes a focus issue because the team spends more time explaining the platform than improving the product. And even if you could absorb all of that, the next layer of drag usually comes from the contract model itself. How rigid API contracts become digital red tape. Then the slowdown moves from runtime behavior into team behavior. API contracts are supposed to create trust, and that part is real. A service should know what it can expect, and a consuming team should not wake up to random breaking changes. The problem starts when the contract stops acting like a shared agreement and starts acting like a border crossing, because every small change now needs permission, sequencing, review, and rollout choreography before anyone can ship. Take something boring, like renaming one field. In a tightly coupled business flow, that should be a local refactor. In a rigid service landscape, it can trigger a whole chain of work. Update the schema, notify consumers, debate whether the change is breaking, add a new version, keep the old version alive, coordinate release windows, and then wait for every dependent team to catch up. The technical change is tiny. The organizational motion around it is not. That's where contracts turn into red tape. Not because contracts are bad, but because teams often lock them too early in domains that are still moving. Research on API contract rigidity points to low contract testing adoption, around 17% of teams. So a lot of organizations don't have a fast, reliable way to verify consumer and provider expectations in the pipeline. They fall back to slower end-to-end testing, manual checks, or plain guesswork between teams. None of that scales well. And when confidence is low, governance gets tighter. More approval steps, more review boards, and more checklist thinking. More don't merge this until architecture signs off. That response makes sense if you're trying to prevent outages, but in practice, it often pushes governance outside the developer flow where it turns into queue time instead of feedback. Research after 2025 is pretty clear on this point. Governance slows teams mostly when it stays manual, rigid, and disconnected from the tools people already use. So what do developers do? They work around it. They duplicate endpoints. They avoid changing old APIs, and they add translation layers nobody wanted. They ship another version and promise to clean it up later. Now the system has more surface area, more drift, and more hidden maintenance. The policy was meant to create order, but because the model is too stiff, it creates more exceptions instead. There are a few warning signs you can watch for. High contract churn usually means the domain isn't stable yet. Low verification success means teams don't actually share the same understanding of the interface. Flaky checks often mean the contract is too strict in places where variation is normal, like generated IDs, timestamps, or optional fields. If the contract fails all the time, people stop trusting the process. Then the contract becomes ceremony, not safety. This gets even stranger with AI coding tools. AI can help generate handlers, clients, tests, and schemas faster, but that does not remove the bottleneck. It just pushes more code into a pipeline that still depends on human approval, brittle checks, and cross-team synchronization. Research on the AI velocity paradox makes this point clearly. Local coding speed rises, while downstream validation becomes the new wall. So developers feel productive on their machine and blocked everywhere else. That gap matters. Because from the inside, the team thinks it's moving. Pull requests are open, code exists, and stubs compile. But the system only changes when the contract path clears, and in many companies, that path is slower than the coding itself. That's digital bureaucracy in its cleanest form. Not no work, but work that waits. The fix is not to throw governance away. The fix is to change the model, put policy in CI, run checks on pull requests, and fail fast where the developer can still act. Treat contracts as living products with owners, version rules, and feedback loops. Use tolerance where the domain needs room to evolve instead of pretending every response shape will stay frozen forever. Strong governance can help velocity, but only when it behaves like infrastructure, not committee process. Once contracts harden too early, teams usually reach for one more tool to force certainty back into the flow, and that's where distributed transactions enter the picture. The category mistake: distributed transactions in modern .NET. Once teams lock down their contracts too hard, they usually try to find certainty somewhere else. That is exactly where distributed transactions show up, and the thinking usually sounds pretty reasonable at first. We split the system into separate services with their own databases and release cycles, but we still want one clean yes or no outcome across the whole flow. Payment succeeds, inventory commits, and the order status updates so that everything stays perfectly aligned. If any single part of that chain fails, we just roll the whole thing back. It sounds neat on paper, but it assumes a distributed system can behave like one machine. And that is the category mistake. You designed for network boundaries and independent failure, but then you asked the runtime for the kind of certainty that only works inside one process. Those two ideas pull in opposite directions. The more you spread a workflow across different services, the more fragile that promise becomes, because success now depends on connections and coordinators you do not fully control. In plain language, a two-phase commit tries to solve this by using a referee. The coordinator asks every participant if they are ready to commit, and if everyone says yes, it tells them all to finish the job. If even one participant says no, the coordinator tells the entire group to abort. This can work inside tightly controlled environments, but in cloud-native systems, it starts fighting the grain of the platform. Networks wobble and services restart, which means a timeout does not actually tell you if the work failed, it just means you stopped knowing what happened. That distinction matters more than most people realize. In modern .NET, the situation gets even tighter because distributed transaction support is no longer the smooth default it was in the old framework days. Starting with .NET 7, this support is Windows only and requires you to explicitly set implicit distributed transactions to true. If you forget that step, you will hit an exception telling you the feature is not enabled. Even the platform is telling you to slow down and think before you try to use it. Then there is the issue of promotion, which often catches teams off guard. You might start with what looks like a normal local transaction, but then an extra database connection appears through a query path you did not notice. Suddenly, that harmless-looking query triggers a promotion into a far more complicated transaction. Research into .NET adoption failures shows this exact pattern over and over. The code is no longer simple or portable, and it becomes tied to a much narrower operating path than the team expected. The trouble only gets worse when you look at real distributed flows. If one service writes data and another one stalls, your rollback logic is no longer clean or reliable. You might not know if the remote side committed the change or if it never saw the request at all. The system lands in an uncertain state, which is the exact problem architects try to design away after they have already created the conditions that cause it. That is why we see so much talk about sagas and outbox patterns. These patterns do not pretend the network is stable enough for one giant atomic unit, so they accept local transactions and coordinate through events and retrace. In the right scenario, that is definitely the better choice, but you have to remember that it adds orchestration work and more failure paths that your team now has to reason about every single day. The lesson here is not that you should use sagas for everything. The deeper shift happens much earlier than that. You should stop turning a cohesive business process into a cross-service workflow unless that physical separation solves a massive problem for you today. If the order flow and the pricing rules still move as one unit in the business, keeping them close together is almost always the simpler and safer design. Once teams see that tax clearly, they have to ask a hard question. Should these things be separate at all? What the market correction is telling us. The response to these architectural headaches is finally starting to show up in the market. And this is not just a trend post or a branding shift, but a genuine correction in how we build software. A growing number of organizations are pulling services back into larger deployment units, and they are doing it because companies rarely undo their architecture for fun. They do it when the operating costs and the friction stop matching the value they were promised. This is not about being nostalgic for old systems, but a realization that many distributed setups were solving future problems by creating massive present-day drag. The Amazon Prime Video case is a perfect example of this shift. One of their internal teams moved from a distributed design back to a monolith, and they managed to cut their infrastructure costs by more than 90%. While that number gets a lot of attention, the deeper lesson is that their product was video analysis rather than orchestration. The architecture had become too visible in the cost structure, which usually means the system is spending way too much energy just managing itself. Shopify shows us the same lesson from a slightly different angle. They have huge scale and a massive code base, but they maintain strong internal boundaries and only extract services when there is a reason strong enough to justify the wait. This model is important because it breaks the lazy argument that a single deployable unit equals amateur engineering. A single deployable can be disciplined and modular, but the difference is that separation stays as an option instead of being a forced default. The debate itself is what really needs fixing. Framing this as monolith versus microservices is a mistake because it turns architecture into an identity. Teams start defending their camp instead of looking at the work. So the better question is simply where physical distribution creates real business value. You have to find where it creates value and where it just creates admin work around code that actually belongs together. That is where the modular monolith becomes incredibly useful. It is not a compromise, but a deliberate structure that gives you one deployable unit with clear internal boundaries. You still design for separation, but that separation stays inside the process until the pressure to move it outside becomes real. This means you keep the speed of local calls and the simplicity of one deployment path while keeping your transactions safe. For engineering teams, this changes the day-to-day work almost immediately. Tests are easier to run because the behavior lives in one place, and debugging is faster because the evidence is not scattered across 6 different systems. Refactoring becomes safer because a business change can stay local for a longer period of time. New developers get productive much faster because they can run the system and follow the flow without stitching together a miniature platform on their laptop. Executives feel the difference too, even if they never look at a single line of code. They see lower total costs and fewer platform dependencies, which leads to less coordination overhead hiding inside their roadmaps. Delivery becomes more predictable, and onboarding gets simpler, especially in cases where hard isolation was never actually a requirement. In a world focused on FinOps, architecture is no longer judged by how elegant it looks on a whiteboard, but by what it costs to run. None of this means that microservices are inherently wrong. They still fit cases with massive scaling differences or team structures large enough to support that kind of model. But the market correction is sending a very direct message that premature distribution is expensive. Many teams are finally admitting that a clean diagram is not the same thing as a fast or reliable system. The practical move right now is not to start a massive rewrite crusade. It is about triage. You need to look at which separations actually create business value and which ones only exist to preserve an idea of purity. Some services definitely need to stay separate, but others probably should have never been split in the first place. Once you accept that reality, the next step is figuring out how net teams decide what stays out and what should never leave the process. A practical decision model for net teams. So what do you do with this if you're running a net team right now? Start with one question and keep it blunt. What problem requires physical separation today? Not someday. Not if the company triples. Not because a reference architecture says it's cleaner. Today. If you can't answer that in one sentence, the safest default is usually to keep the capability in process and design the boundary inside the code first. The reasons for separation are real, but they're narrower than most teams admit. Uneven scaling is one, compliance isolation can be another, and a large team with stable ownership lines can be one too. A domain that has settled down enough to support durable contracts is also a valid reason. But if the answer sounds fuzzy like flexibility, future-proofing, or best practice, that usually means the case is still too weak. This clicked for me when I started treating architecture like an expense account. Every new service spends something, another repo, another deployment path, another interface to maintain, another place to instrument, another source of failure. If that cost doesn't buy a clear business advantage now, you're just moving work out of the app and into coordination. That's why module design matters more than service count. Split by business capability, not by technical layer and not by fashion. Orders, pricing, billing, inventory. Keep those boundaries explicit in the code and make access intentional. A modular monolith is not one giant shared mess, but rather one deployable with rules. The extraction path stays open later because the capability boundary already exists, which means you just haven't paid the runtime tax yet. The same discipline applies to governance. If a contract check matters, put it in CI. If a schema rule matters, validate it in pull requests. If an API standard matters, lint it automatically. Don't force developers to wait for a meeting to learn that a rule was broken. Fast feedback keeps governance real, while slow feedback turns it into queue management. Observability needs the same restraint. Trace critical paths first. Revenue flows, failure-prone flows, customer-facing bottlenecks. Don't trace everything by default just because the platform can. Most teams don't have an observability problem, they have a prioritization problem. The same goes for service mesh. Don't start there. Use it when the traffic policy or security need is concrete enough to justify the extra moving parts. For consistency, prefer local transactions where the work is still local. When systems do need to communicate, use patterns like outbox and events instead of forcing one giant commit across boundaries. That won't remove complexity, but it keeps the complexity honest. You're no longer pretending a distributed workflow is a single database, right? And then measure the architecture by outcomes people can actually feel. Lead time for changes, debugging hours, deployment friction, cloud cost, onboarding time. If those numbers are getting worse while the diagram gets cleaner, the diagram is lying to you. So here's the challenge. Pick one service in your estate that nobody can justify clearly anymore. One service that changes with another service almost every time. One service that exists mostly because it was split once and never questioned again. Ask whether it should still be a service or whether it should become a module again. Because the real decision was never about purity. It was always about delivery capacity. And So the shift is simple, even if the cleanup isn't. Stop treating distribution like maturity and start treating speed like the thing you protect. If small changes keep triggering coordination, the model is wrong. Audit one recent feature from idea to production. Count the services touched, contracts changed, approvals needed, and tracing required. Then ask one hard question. Did that separation help the business or just the architecture diagram? If this changed how you think, subscribe, leave a review, and connect with me, Mirko Peters, on LinkedIn with the next architecture problem you want unpacked.